This is an experimental low-power nuclear reactor. It is unshielded, for there is no radioactive hazard until the piles of uranium-235 are brought together. When this happens, atomic fission will take place.
We're leaving the silo now.
Clear the silo area. Clear the silo area. The reactor is now going critical. The silo reactor is now going critical.
The atom has become the symbol of our time. For centuries, it was believed to be indivisible, unchanging, the ultimate particle of matter. But we have learned that the atom is in constant motion and change, divisible and more divisible. What is an atom? What is matter? Why is it sometimes solid, sometimes liquid, or vapor? Is there logic, order, and symmetry in the universe? Is there a world of antimatter somewhere beyond our own? Those who look to science spend a lifetime in basic research in the hope of finding a fragment of the answer. Research in a realm far beyond the familiar limits of our senses, far beyond the reach of our most powerful microscopes. In 1947, our government took a giant step towards increasing scientific knowledge. The Atomic Energy Commission set up Brookhaven National Laboratory, a scientific community for nuclear research. It would be administered by a private institution sponsored by cooperating universities. Provided now with an annual budget of over $50 million and charged with the responsibility of maintaining a hospitable environment for creative research. Research at Brookhaven is the pursuit of basic information along the whole spectrum of nuclear science. A world of numbers and symbols. Mountains of information. Monkeys, mice, and snapdragons. Reactors, hot labs, accelerators, remote mechanical manipulators. And the products of Brookhaven are books, reports, forums, and lectures. And conversation that is casually abstract.
Yes, if you want to expand it as a power series, then you have a series of stiltjes, and this has quite a number of interesting properties as summarized in this theorem, which is quite an achievement to prove this, because there are so many functions for which one can't get these nice results.
Do you have any reason to believe that the perturbation series for the anomalous moment of the electron would satisfy any of the appropriate criteria, such as being a series of stiltjes?
Yes, in the Perez model field theory, we've recently been able to show that, in fact, the S-matrix elements are always the difference of at most two series of stiltjes, each of which can be Pade approximated separately. And the same may perhaps be true here. We would have to investigate that.
Who is he? He's one of the 1,000 scientists working at Brookhaven. He may come from any university or private research group in the United States. He may come from a country in any part of the world. Whatever his origin, mathematics is a second language in which he communicates easily with fellow scientists anywhere. Brookhaven is located in Upton, Long Island, a hospitable place to live and work. But it is not climate and convenience that are its chief appeal. What attracts scientists to Brookhaven is its massive complex of research hardware. The 4 million electron volt Van de Graaff electrostatic generator, the 60-inch cyclotron producing 40 million electron volts, the cosmotron, the 3,000 million electron volt accelerator, and over 10 times more powerful, the 33 billion electron volt Alternating Gradient Synchrotron, largest accelerator in the world today. The highly sophisticated AGS was designed to study matter by transforming it.
Excitation is on. 4, 5, 2.
High-energy bursts of protons are shot from the 110-foot, 50 million volt linear injector. Within a second, they travel 300,000 times around the accelerator ring, reaching a speed just short of the speed of light. When a target is placed in the beam, the protons collide with the nuclei of target atoms, shattering and transforming the atoms, at times creating new particles. Some of these particles are guided through a closed channel to the 80-inch bubble chamber, where stereo cameras eyewitness the collisions and record them on film. Streaking through superheated liquid hydrogen, the charged particles leave vapor trails, which make their curious movement visible. These subatomic footprints are significant to the trained eye. Some of these collisions produce new particles, which are given names like K meson, lambda, omega, and pi meson. These events are keys to the secrets of the atom. Certain events discovered by AGS experimenters have challenged long-held theories about the structure of the universe. The endless flow of photographs taken in the bubble chamber must be carefully scanned for significant patterns that show nuclear interaction. Is this event something unique or something we already know? Special instruments help make these distinctions, like the flying spot digitizer, which can analyze particle track film in seconds. The information is finally passed on to ultra-high-speed computers for analysis and storage. One series of experiments, which would have previously taken physicists 10 precious years, lasted only a few months. The AGS is presently the largest accelerator in the world, and it is not large enough. New and more versatile accelerators and reactors are in design, because paradoxically, The deeper we probe into the nuclear bowels of the atom, the more resisting are the forces binding the particles. The Brookhaven Graphite Research Reactor was one of the first atomic piles designed for basic research. After more than 15 years of continuous service, this great prototype is still very much in demand. Members of the biology department schedule considerable time on the graphite reactor with experiments in genetics and radiation effects. The mice being lowered into the reactor will be exposed to intense radiation. Excessive exposure will make them grow old prematurely. They will be studied for the causes of aging. And what is learned may one day ease the haunting problems of old age for humans. The most recent super machine at Brookhaven is the High Flux Beam Research Reactor. The HFBR is used to study the interaction between solids and neutrons. Intense beams of neutrons are emitted from reactor ports. And when a target is placed in a beam's path, the neutrons will be scattered from atomic particles in the target in characteristic patterns which reveal the atomic architecture of the crystal. These experiments are controlled by high-speed digital computers, which record the constant flow of data, stack it neatly away, process it, and later recall it easily for the experimenter. Brookhaven is the focal point for radiation research and development in the United States. And the key facility for this work is HIRDLE, the High Intensity Radiation Development Laboratory. Radiation exposure kills the microorganisms that cause food decay. With Brookhaven-developed gamma sources, experiments show that food, when irradiated briefly, can be stored without refrigeration for months without spoiling. 1,000,000 curies of Cobalt-60. The mud puppy is a primitive creature who has both lungs and gills, and a simple cell structure that makes him a good subject for the relatively new field of cellular radiobiology. How does radiation affect living cells? To what extent can controlled exposure alter growth and reproduction? Radiation is one of the hazards of manned probes into deep space. Brookhaven biologists are working with NASA on a biosatellite program in which plant samples, like Tradescantia, are orbited in a gravity-free laboratory, testing the effects of weightlessness and cosmic radiation. Heavily shielded chambers and radioactive materials are the nuclear laboratory of the radiobiologist, essential to the search for clues to basic questions. What causes mutation? Can species be improved by irradiation? How much exposure can a chromosome stand? The answers may tell the secret of creation and reproduction. How does life begin? How does life end? The destructive power of atomic radiation has been more than amply demonstrated. Its long-range effects on plant life and ecological systems are explored in a secluded Brookhaven forest. Daily exposure to a source of 9,500 curies of cesium-137 has altered the balance of nature, creating an experimental wasteland. But certain forms of life persist. Primitive lichen flowers here. Clumps of grass find shelter behind dead stumps of trees from the lethal gamma rays. Handling intense radioactive materials was once a hazardous occupation. However, with the use of remote manipulating hands and over a yard of leaded glass separating technicians from the hot material, nuclear engineering has eliminated the risks. Radiation sources take a number of forms. They may consist of a byproduct of reactor operations like cesium-137, or unstable isotopes created by neutron irradiation like Cobalt-60. They are treated and made ready for use in heavily shielded cells called hot laboratories. The atomic age has converted the study of chemistry from a science screened off from physics by a curtain of test tubes to a partner of physics. Chemists discovered the atom. Physicists revealed the atom's parts. Brookhaven chemistry is nuclear, radiation, and physical. The atom is the starting point. Chemists have learned to analyze works of art. Brush strokes, color composition, pigmentation are revealed through radiographs to tell us secrets of painting which we thought had died with the old masters. Archeological finds can now tell us more about their origin and history by neutron irradiation in a reactor. Scrapings from an ancient vase will serve as a sample for analysis. The sample is prepared for the graphite reactor, where it will be irradiated for a given length of time. Our archaeological scrapings are now radioactive, and their radiation can be measured and analyzed, thus determining their composition. Nuclear medicine took some of its first major steps at Brookhaven's medical facility. Primarily a research hospital, patients are brought here for observation or therapy related to advanced research programs, like the study of high blood pressure. The ancient Chinese warned of rich food and too much salt. Brookhaven doctors have been studying the link between salt intake and high blood pressure. By selective inbreeding, they have developed a strain of rat that rapidly develops severe and fatal high blood pressure when the animal is put on a heavy salt diet at weaning. Unless salt is removed from its diet, this rat will be dead in a short time. Another strain of rat has been developed, which, despite a high salt diet, will never develop high blood pressure. The radioisotope called Technetium 99M is being prepared in the hot laboratory on special order for the Brookhaven Medical Center, where it will play an essential role in diagnosing certain maladies. Although it contains a high degree of radioactivity, Technetium 99M is injected into the patient with no danger, for it has a short half-life and will disappear within a few hours. The patient has an abnormal thyroid condition and has been receiving treatment for some weeks. The technetium can be traced precisely by scanning the area around the thyroid, counting the unstable emissions as they decay. Technetium scanning results in remarkably accurate pictures of even subtle changes in the diseased area. This member of the Brookhaven faculty is called the Phantom. He has a complete set of plastic organs, which, when filled with a radioactive substance, act as a calibrator for the whole body counter. Before and after patients are given isotopes, the whole body counter is used to measure the radiation present in the individual. Radiation can harm, but has it the power to heal? This calf has leukemia, for which there is no known cure. Recent experiments have shown that the cancerous white cells of leukemic blood can be treated with some success by irradiation, but not safely within the body. Treatment is now done by channeling the blood to circulate outside the body, around a radioactive source, and back again. The calf's heart is the only working part, pumping the lifeblood along its external course. Now that the technique called extracorporeal irradiation of the blood is perfected, it is being used with human leukemia patients at the Brookhaven Hospital. A cesium-137 gamma ray source is the irradiator, helping to hold down the leukemic cell population of the blood that pulses around it. Blood irradiation cannot cure leukemia, but it may prolong this patient's life. Brookhaven is basic research in physics, chemistry, nuclear engineering, mathematics, in biology, and medicine. The atom is the common denominator. The wonder of Brookhaven is that each new direction in research creates a chain reaction of possibilities, a whole new spectrum for the future.